This photograph shows the traditional assembly line of a classic animation studio. Bringing a single story to life required entire buildings filled with artists, painting thousands of individual frames by hand over the course of years. The massive entertainment empires built from this labor relied on a specific foundation of intellectual property. But the original stories behind those sketches, tales like Snow White, Cinderella, and Alice in Wonderland, exist in the public domain. They belong to everyone. Look at this sprawling, modern studio campus. Independent creators have always had the legal right to adapt those classic fairy tales, but they lacked the physical real estate, the massive server racks, and the armies of technicians required to actually produce them. That physical infrastructure can now be entirely replaced by a series of automated steps. By stringing together specialized artificial intelligence tools, a creator can build a complete digital pipeline that runs on code and raw computing power instead of brick-and-mortar departments. With the physical barriers removed, a single person working from a laptop commands the same production capacity that used to require a corporate giant. Operating this digital studio starts in the legal department. The system is instructed to only process the original public domain texts. If a story has been adapted into a modern film, those specific character designs and trademarked names are strictly filtered out to maintain a clean copyright boundary. Next, the raw 1865 text of a book like Alice in Wonderland is fed into an LLM. An LLM, or large language model, is a type of artificial intelligence trained to understand and generate human text. Here, it acts as the head of story. The model scans chapters of dense prose and slices the narrative into highly specific, controllable blocks. Each block is timed to represent exactly 5 to 15 seconds of on-screen action. This diagram illustrates exactly how that text is digested. The heavy paragraphs are stripped down and separated into distinct instructions: the spoken dialogue, the physical movements of the characters, and precise directions for the virtual camera. The extraction process converts a static novel into a structured, programmable blueprint for video generation. But an AI cannot simply read that blueprint and animate it without strict visual rules. Left to its own devices, it will suffer from visual hallucination, a flaw where the model generates unintended or inconsistent imagery not grounded in the prompt. To stop this, we build an automated art and sound department. Specialized vision models generate static reference materials for every element in the scene. They lock in a specific watercolor look for Alice's blue dress and dictate the exact shade of green for the Mad Hatter's top hat, ensuring those elements never deviate. At the exact same time, audio models are synthesizing the required soundscape. They generate the distinct ticking of the White Rabbit's pocket watch and clone a specific voice profile for the Hatter's laugh. All of these raw assets are organized into this document, a JSON manifest. JSON, or JavaScript Object Notation, is a standard text-based format for structuring data, so machines can easily read it. This file acts as the digital director's binder. Zooming in, you can see how the blueprint controls assets. Using strict tags like @ImageAlice or @AudioLaugh, the system permanently binds pre-approved image and sound files directly to the text instructions for that specific scene. Tying these isolated files together into a single rigid document forces the generation models to maintain perfect continuity from the first frame to the last. The completed manifest is then sent to the render farm. Here, the data is processed by a quad-modal video generation model. Quad-modal means the AI is capable of processing 4 different types of inputs simultaneously: text, image, audio, and video. Because the model can read 4 data streams at once, it outputs a result like this. The text directions, the watercolor reference images, and the ambient sound files are fused into a cohesive, perfectly synchronized animated clip. Before this clip is approved, it hits a human-in-the-loop checkpoint. A human creator reviews the footage, specifically searching for errors the machine missed, like the Hatter's hat rendering as purple instead of the mandated green. If an error is caught, the creator simply adjusts the text prompt or swaps the reference image in the manifest, then pushes a button to run the scene again. The heavy lifting, the thousands of brush strokes and audio syncing, is handled entirely by the brute force rendering of the AI. The human is left to focus entirely on maintaining the accuracy of the story. A traditional animation studio required millions of dollars to fund its departments and server rooms. Today, renting the necessary cloud GPUs, the graphics processing units that calculate and render complex visual data, costs about 10 to 20 cents per second of final video. This photograph of early desktop computers captures the moment massive computing power became accessible to individuals. Because the pipeline is managed by simple text files, a solo operator can batch process entire series while they sleep. Production capacity is no longer locked behind the gates of a massive corporate campus. A solo operator now wields the exact same output potential as a 20th century studio. Yet all this advanced computing power relies on the same foundation. The raw material driving the algorithm is still a 150-year-old fairy tale. The friction of putting a story on screen is gone. Success in animation relies entirely on a creator's ability to select a timeless narrative and direct it.